We're doing another kind of differentiation, another kind of finding the derivatives. It's called implicit differentiation. Now, if I were going to solve this the way that we have before, I would first have to solve this for y. And then I could take the derivative, because now I know that the derivative of y would be the derivative of this. That would be the same as negative x squared plus 4 raised to the 1/2 power. Still that plus or minus would be there. To the negative 1/2 power multiplied by negative 2x. So this would be the derivative sort of the old way, where we just get y by itself and then find the derivative. Well, I'm going to do the same problem, but I'm going to do it another way.
Sebastian,
Alright, this old way, you don't have to solve for y in order to be able to solve the problem. You can just take the derivative as you go. Now, you have to keep in mind that as you're taking the derivative, that y is a function of x. So this part right here, it's kind of like saying that's a f of x right there. And you know how you have to always go back and take the derivative of what was inside? You have to take the derivative of what was inside here as well, only for the y's. So the derivative of x squared is 2x. The derivative of y squared is 2y, but I have to take the derivative of whatever y represents, so I have to put a y prime with the y. And then equals 0. We're trying to find the derivative of y, so I'm going to solve for y prime. I'm going to subtract 2x, divide by 2y, and I get negative x over y. And this is okay for the derivative. Now, I want to go back just a second. It says negative x over y. Well, this is what y was, or that was the derivative, I'm sorry. This is what y was right here. And this is telling me that the derivative is negative x over what I have circled, and if you go back to what we said the derivative was, that's the same thing, it's just written a different way. And it's a lot less complicated to write it this new way because of the way the process works. It is going to have y's in the answer, and that's okay to have y's in the answer. So let's do another problem. Alright, let's find the derivative of x squared, that's 2x. The derivative of 2xy, I have to think of that like the quotient or the product rule. The first times the derivative of y. The derivative of y is 1, but I have to take the derivative of the inside, so I've got my y prime. Plus the second times the derivative of the first. Alright, 3y squared, the derivative of 3y squared would be 6y. The derivative of y is y prime. Anytime I have a y, I take the derivative of y with it because y is a function of x, and so I have to multiply by its derivative. Alright, I'm going to try to solve for y prime, and the way I'm going to do that is to get everything that has a y prime by itself. So this part and this part's going to stay, but I'm going to move the 2x and the 2y to the other side. Alright, on this side I'm going to factor out a y prime. And then I'm going to divide by 2x plus 6y. Sometimes they do divide out common numbers, so we could divide out a 2 if we wanted to. I would count it correct if you did not do that. So there's the derivative of y. Another way that you can write the derivative of y is dy dx, the derivative of y with respect to x. You're going to see both of those notations when you do these problems. Okay, here's another one. The derivative of x squared is 2x. The derivative of 2y to the third would be 6y squared times the derivative of y, which is y prime, which equals 0. We're going to move the 2x to the other side. And then we're going to divide by 6y squared. You can leave it like that, or you can reduce if you want. And there's the derivative. Okay, here's another one. We're going to take the derivative of y to the fourth, so that would be 4y to the third times the derivative of y. The derivative of y is just negative 1 times the derivative of y, so negative y prime. Okay, derivative of x to the third is 3x squared. Derivative of x is 1. And we don't have to put x prime or anything like that because x is not a function of something. Y is a function of x, and that's why we always put the y prime. Alright, we already have our y primes together, so we're going to factor out a y prime. And then we're going to divide by what we factored out. Alright, here's another one. We have to do the product rule here, and you know what, I'm going to make that a minus or a negative at the front just so I can show you what you should do with that. You're going to do the product rule. Keep in mind that that minus is there, and if you want to put it with the x, that would be fine. So there'd be first times the derivative of the second plus second times the derivative of the first. That's where the negative comes from on both of those pieces. Plus 3 plus the derivative of y, which is y prime, equals the derivative of 1, which is 0. So I'm going to leave my things with the y primes together, and I'm going to move everything else to the other side. I'm going to factor out a y prime. And then I'm going to divide by it. Okay, here's another one. This one has a cosine in it, so it looks more complicated. It's kind of the same though. Still going to do the product rule first times the derivative of the second. The derivative of cosine is negative sine plus the second times the derivative of the first. And then the derivative of 15y would be 15, and then the derivative of y is y prime. Again, I want to move everything with y primes together and everything else to the other side. So I'm going to leave my cosine of x and y prime on that side, subtract my 15y prime, and then add the y sine of x. Factor out a y prime. And then divide. Alright, here's another one. And the question might ask you to find, I think this is supposed to be dx dt. Or dt dx. That was right. This is telling me that t is like the y. And so I'm trying to find t prime if I want to write it like that, where x is my variable. So I'm going to start by finding the derivative of sine of something, which is cosine of the thing. But then I have to multiply by the derivative of the inside, the derivative of x times t. I'm going to use the product rule first times the derivative of t prime, plus the second times the derivative of the first, which is 1, and then the derivative of t again is t prime. I'm doing the t primes because t is like y. Alright, I want my t primes together, and one of the things that I think is the easiest is go ahead and just multiply this right here. So I'm going to make it x t prime cosine of xt plus t cosine of xt equals t prime. Okay, at that point I can get everything that I need to get together. Move my t prime over. Move the t cosine of xt over. trying to find t prime, so now we're going to factor out what that is and divide by it, and I'm going to do it all at the same time. So this is what I'm taking out, which means I'm going to be dividing by that other stuff, so that would be dividing by x cosine of x minus t minus 1, and then the top is going to be the negative t cosine of xt, which should really be in parentheses right there. It's very strange, but the process is pretty simple and pretty straightforward. Alright, here we go. Here's another one. So I'm going to find the derivative, bring down the 4, raise it to the third, find the derivative of the inside. Derivative of x is 1, the derivative of y is y prime, and then the derivative of y to the third would be 3y squared, and then y prime. Several ways you can solve it, but I think what I'm going to do is I'm going to take all of this and multiply by each thing. Then I'm going to subtract over this thing with the y prime so I can get the y primes on the same side. I'm going to skip a step, and I'm going to divide by the parts that's with y prime. And then the top will be that 4 times x plus y to the third. Alright, so then let's find the derivative of this one. The derivative of tangent of y is 1 over cosine squared of y times y prime. The derivative of x squared is 2x. The derivative of y is y prime. Again, I want everything that has y primes together on the same side. I'm going to factor out what's in common. And then I want to divide by it. So you can have fractions over fractions, and that works okay. Now a problem might ask you to find dy dx at a point. And if a problem asks you to do that, you're just going to find the derivative the way that we just have been doing it, and then we're going to plug in the x and the y, the 1 and the negative 1. So we're going to have 2 times x plus 2 to the first times derivative of the inside. Okay, and then we're going to have minus 12 2y plus 3 to the first times the derivative of the inside. The derivative of 2y would be 2y prime, and then equals 0. So we're going to move the 2x plus 2 to the other side. And then we're going to divide by all this stuff. You can divide by it all at one time. And then you can simplify if you want. Like you can get rid of the 2's maybe. The only thing that will do is just make it a little bit easier whenever we plug in the numbers. Because to find the derivative at 1, negative 1, we now plug in 1, negative 1. So we would have 1 plus 2 over negative 12 times 2 times 1 plus 3. Two times negative 1, negative 2 there. So that would be 3 over negative 12, which is negative 1/4. And I realize there's still a negative here, so there's really a negative on top. And that makes there be a negative there, which makes the final answer not be negative 1/4, but only be positive 1/4. Here's your try problems. X to the third plus 7y to the fourth equals 13. X plus xy plus y equals sine of 2x. X squared plus y squared equals 1, and I want to find the derivative at 3/5, 4/5.